The energetic flow did not simply peter out, but instead moved a few dozen more meters over the water. While this was occurring, part of the pyroclastic flow entered the water, thus displacing it, and through this interaction generated a small-scale tsunami. This tsunami would then go on to crash against the island's shoreline, perhaps at one point reaching a very modest height of 12 inches or 30 centimeters. Because of this tsunami's minuscule height, it of course did not cause any damage. However, it represents a great case study for analyzing some of history's more destructive volcanic tsunamis, which were several orders of magnitude larger. For example, on January 15th of 2022, the Hunga Tonga Hunga Ha'apai volcano in the nation of Tonga exploded, producing a tsunami wave which was initially estimated to be 90 meters or 295 feet tall. These tsunami waves were generated through a combination of factors such as the blast wave itself, but recent research suggests the main wave was generated by pyroclastic flows. Although pyroclastic flows are gas-rich, it is best to imagine them as superheated landslides in the context of displacement. Thus, when entering the water at high speeds, they can create significant displacement, especially since during some major explosive volcanic eruptions, the volume of pyroclastic flows can exceed more than a cubic kilometer in volume. Another example of a pyroclastic flow-generated tsunami occurred in 1883 when pyroclastic flows unleashed by the caldera-forming eruption of Krakatoa in Indonesia raced into the adjacent sea. This created a tsunami with a maximum run-up height of 41 meters or 135 feet, which would go on to cause the majority of that eruption's casualties. However, pyroclastic flows and landslides triggered by edifice collapse, such as what occurred at Krakatoa in 2018, are not the only potential causes of volcanic tsunamis. For example, during Hunga Tonga's eruption, a smaller tsunami was seen preceding the main wave. This smaller wave even reached locations in the Caribbean and represented a phenomena known as a meteotsunami. In that case, the climactic explosion of the volcano created a powerful shockwave that raced around the planet, causing a short-term spike in atmospheric pressure. As this pressure spike raced around the ocean, it temporarily pushed water down. After the shockwave moved beyond, the ocean rebounded slightly, forming a discernible wave. While explosions above water can generate tsunamis, ones below the surface at submarine volcanoes can be equally destructive. The final potential cause of a volcanic tsunami is caldera collapse. When a large volume explosive eruption occurs, it can significantly drain a volcano's underlying magma chamber. This can cause the rock overlying the magma chamber to collapse downwards to fill the empty space, resulting in a caldera collapse. This drop of rock, if it occurs relatively quickly, can then generate a volcanic tsunami. As a final note, the Stromboli volcano has generated at least 2 notable tsunamis in the last 1,000 years, which were several orders of magnitude larger than what was witnessed on October 12th. One such tsunami was generated in 2002 with a wave height of 33 feet or 10 meters, while an even more destructive tsunami that was also caused by a volcanic landslide in 1343 devastated the